Greetings, students. Today we're going to discuss practice test 2-2. Let's begin. Question 1. Find the distance between each pair of points. So when we're doing distance, we use the distance formula. D is equal to the square root. And we put the x's first. So we're going to do 6 minus -5 squared. And then we're going to put the y's next. So we're going to do -4 minus -6 squared. So minus negative becomes a plus, so that becomes 6 plus 5, or 11 squared. And then minus negative becomes a plus, so that becomes a -4 plus 6, so that becomes a 2 squared. So I have here 121 plus 4, which is the square root of 125. The reduction here is 25 times 5, because 125 is 25 by 5. So my finished answer will be 5 root 5, because 125 divides by 25 5 times, and the square root of 25 is 5. Next question, find the midpoint. So here the x's have stayed the same. So the midpoint for the x's, of course, is going to be 6, because if you take 6 plus 6, you get 12, and half of 12 is still 6. For the y values, if you take -9 plus 3, you get -6, and half of -6 is -3. So my midpoint is 6, -3. Again, you add the x's, divide by 2, and then you add the y's, divide by 2. Next question. These are both interior angles because they're in between the lines, and they're on the same side, the right-hand side of the transversal. So we're going to call this consecutive interior because they're on the same side of the transversal, inside. Now, if one of them was on the left-hand side, we'd call them alternate interior. If one was on the left-hand side with that one on the right-hand side. This one of them's exterior and one of them's interior. So when I have an exterior and an interior set, that's either going to be a vertical or a corresponding set. So in this case, it's corresponding because they're not across the diagonal from each other. So one of them is interior, one of them is exterior, so it must be either corresponding or vertical. And it's corresponding. They're in the same spot, in other words. Question 5. So again, here I'm looking at whether they're equal or whether it's the supplement. So this, again, can be copied diagonally. 105 goes there. And then the supplement of 105 is 75. So if I take 180 minus 105, I get 75. So these other two angles on this diagram are 75s on this bottom portion. And we just copy and paste this from the bottom to the top half. So this bottom half copies and pastes. And when we copy and paste it, the question mark's in the same spot as the 75. The 105 would be above it, the other 75 would be to the right above it, and then the other 105 would be to the right of it. So the question here, what I'm asking about is it 75? Now here I've got the same item, that's 75, meaning its supplement is 105. So I can fill in this diagram the same way, it's just got it backwards. And this time again, the question mark, you see it's in the same spot as the 75 once again. So that's a 75-degree angle as well. It's in the same spot as a 75. All right, for this one, these are alternate exterior, or I can think of it as this angle can be transferred here, and then it's in the same spot as that angle underneath. So when they're in the same spot, they are corresponding, or they're congruent, as we discussed up here above. So I'm going to set 10x minus 8 equal in value to 8x plus 10. I'll take 8x from 10x to make 2x. I'll add 8 to 10 to make 18. Then I'll divide 18 in half to get 9. The value of x is 9. With this next one, when I transfer the angles diagonally, they're not in the same spots. So it's in the top right and the bottom right. They're not in the same spots. So these are supplementary. So in other words, what I can do here is I can add them together. When I add them together, I get 35x plus 75. And that will equal, when it adds together, 180. It'll be a supplementary set. I'll take 75 from 180 to get 105. And I'll divide 105 by 35 to get 3. That's my answer for x there. All right, these bottom two angles are these bottom two questions are some new questions this week. Identify each triangle by angles and sides. So we have 3 angle names. So for our angle names, we have acute, obtuse, and right. So acute, obtuse, and right are angle names. So let's look at these two triangles and let's talk about the angle name first. So if all the angles are less than 90, all of the angles, not just 2 of the angles, but all of them, if all of them are less than 90, like on this picture, we can call that an acute triangle because all of them are less than 90. If 2 of them are less than 90, but one of them is equal, we call that a right triangle. Question 10 is a right triangle. If 2 of them are less than 90 and one of them is bigger than 90, that's an obtuse triangle, where one angle is greater than 90. The side names. We have scalene, isosceles, or isosceles, depending on how you say it, and equilateral. So when I look at the sides, if all of them are different, we can call that scalene. All of them are different lengths, these 3 sides at number 10, 2 1/10, 3 5/10, 2 9/10. All of them are different lengths. That we call that scalene. If 2 of them are the same, we call that isosceles or isosceles. So we have 2, 5, and 8/10 side lengths here on this particular triangle. So that's going to be isosceles. If all 3 are the same, we call it equilateral. Again, so there's 3 options for each name, 3 options for the angles, 3 options for the sides. You decide which option fits each triangle. You need 1 angle name, 1 side name. Now, if it is an equilateral triangle, it is always acute. So with the equilateral triangle, we could actually just call that equilateral, but it's not wrong to call it acute equilateral. It's just always acute if it is equilateral. So if I did draw an equilateral triangle, all the angles would be 60 on it. And we could call it acute equilateral or just simply equilateral. All right. Let me second step next page. Awesome, and we're back. So when we find the slope of each line, we want to get to the slope-intercept form. The slope-intercept form is solved for y. Y is equal to mx plus b. And that right there is slope. That is slope in front of x. So two of these are solved for y already. So on question 13, my slope is 1/3. And on question 14, my slope is -3. 2 of them have the slope already set up for you in slope-intercept form. Now the rest of these are not technically in slope-intercept form. So the rest of these require a little bit of thought. So let's go with these 2 that are simple variables, x equals and y equals. When we have an x equals any number, that is a up and down line, a vertical line. That means the slope is undefined or infinite. Because it has infinite rise and no run with that particular type of line with x equals 4. Because when you look at that line and graph it on a grid, that line x equals 4, what it does is it goes to the right 4, and it goes straight up and down. And that's what's called an undefined slope because it goes straight up and down. It does not have any run. With question 15, when you have just a y equals a number, that's what's called a horizontal line. That has a slope of nothing because it has no rise. Yeah. sorry, a little bit messy today. A slope of nothing because it has no rise. It has infinite run but no rise. So what that is again, it's a horizontal line with y equals -3. It goes down 3 from the origin. And it just goes straight across. No rise. So here I got no rise, and here I've got infinite rise. No rise and infinite rise. These two lines are actually perpendicular, 12 and 15. They're perpendicular because one of them has no rise and one of them has infinite rise. So we can move on to question 18 a little bit here. Fill in one of those sets. The question with no rise and infinite rise, those two are perpendicular lines. So 12 and 15 would fit this concept. Now other lines here, they're perpendicular. 1/3 and -3. When you flip 1/3, it becomes a 3, and then you negate it. So that is also a perpendicular set. 13 and 14 are also perpendicular. So far I don't have any of these parallel because none of the slopes are the same yet. So we're going to have to figure out which of these have the same slope as soon as we solve this one for y and this one for y to get the slopes. So to solve for y, I'm going to move the x over to the other side. It's going to become -3y is equal to -x plus 3. Then I'm going to divide by -3 to both sides. Divide by -3 to both sides. So that's going to become y equals -1 over -3 is going to be +1/3. So they're both negative, so they make a plus, +1/3. So that's 1/3 x. And then +3 over -3 is -1. So this has a slope of 1/3. Question 11 does. Meaning that it's got the same slope as question 13. There's my parallel set. 11 and 13 are parallel. They have the same slope. All right, question 16. Let's figure out what the slope there is. If I take 8x from both sides, that's going to make this 3y is equal to -8x minus 9. And then when I divide by 3 here, well, 8 doesn't divide evenly by 3. So that has a slope of -8/3. Y is equal to -8/3. And that's +3 on the bottom there. So -8/3 x minus 3. That's a -8/3 slope. So in other words, this is not parallel nor perpendicular with any of the given lines. My final perpendicular set here, because this was 1/3, it's also perpendicular to -3. So 11 and 14 are also perpendicular. All right, so that question's kind of lengthy. It's got a lot of parts to it. So make sure you study how to find slope here because we have a lot of points assigned there with finding slope. It's one of the things we worked in class quite a bit. All right, find the measure of the angle. So each triangle adds up to 180. So I can take 82 plus 45. I can add that together. That's 127. So I have 127 so far accounted for. If I subtract that value from 180, I can get the missing angle. So if I borrow from the 8, make it a 7. 10 minus 7 is 3. 7 minus 2 is 5. 53 degrees is the missing angle there. The angles on any triangle are supplementary. Now here I can do a similar concept. I can add these two together, and then I can set 4x plus 7 equal to that number as well. So if I take 49 plus 88 and add those together, that's 17. That's 137. And I subtract that from 180. I'm going to get, well, borrow from the 8, make it a 7. 10 minus 7 is 3. I'm going to get 43 there. That means that this missing angle, 4x plus 7, must equal 43. I'll take 7 from 43. That'll make that into a 36. Now I'll divide 36 by 4. That'll make x equal to 9. All right. Again, that's not the only way you can write your work here. You could do this horizontally. You could say 4x plus 7 plus 49 plus 88 equals 180. And you can set it up that way if you want to as well. All right, the exterior angle theorem. So this theorem here states that this exterior angle is the sum of the two remote interior angles. You can also think of this as the same way we did question 19. You can find this angle inside, and then this will be the supplement of the angle inside. So if I do 105 plus 51 here, I'm going to get 6, 5, 156 degrees. So this sum is 156. I could subtract it from 180 to find this angle, and then I can subtract again from 180 to get this angle, but then I get the same number as this. So you see, hopefully you see what I'm talking about here. This 156 is the question marks angle, because 180 minus 156 is this angle, then 180 minus that is this angle outside, which is 156. So we don't have to subtract that from 180 because I'm not looking for the interior angle here like I was on number 19. I'm looking for the outside angle, the exterior angle. Question 22 has a similar setup, so I can subtract 136 and 180 to get this inside angle, if I would prefer. And then I can add those up and subtract again from 180. Or I can do the exterior angle theorem. The sum of these two angles makes this angle outside. So I can set this up as x plus 42 is equal to, in value, 136. Because the sum of the two remote interior angles makes this exterior angle. So if I take 42 from 136 here, I'll get my value. So 6 minus 2 is 4, and 13 minus 4 is 9, 94 degrees. All right, next thing, how would you write the congruence statement? So I'm asking what goes with what here on the diagram. So what you do here is you look at the diagram and you say, well, let's start with S. S has the same marking as which other letter? Well, F. These two go together because they have the same marking. Then I move on to T. T has the same marking as which letter here? Well, H, because it's got two markings. So far I've got S with F and T with H. So I'm looking at the statements here. I should have S with F. So this is correct. Letter C is correct. S not with U, no. S not with U, no. S not with H. So it says S with F, that's correct. T with H, that's correct. And U with U. So letter C is the correct option. So I'm asking what goes with what, and it's by these markings. These markings are congruence markings, and it tells you what goes with what. So here on 24, X has two markings. Which other one has two markings? P. So X with P. These two go together. So I'm looking for one that says X goes with P. So this says X goes with R. That's not correct. This says X goes with Q. That's not correct. This says X goes with R. That's not correct. Letter B says X goes with P. So that's correct. Let's check it with the other letters here as well. W should go with R. So it says X with P, W with R, and Y with Q. That's the correct option, letter B. So that is what you're talking about here with this question 23 and 24. We're asking about what goes with what. Anyways, good luck with your test. Hopefully things go well for you. I'll be here Thursday before and after school if you want to discuss it.